Hello everyone, a very good evening. So some celebrations are going here, so I'm audible and visible. I'm visible, I hope, but whether I am audible?
You're audible, but voice is low, ma'am.
Okay, voice is low right
Yeah,
now
now it's
also.
fine. Now it's fine. Now it's fine.
Okay, okay. So we will start the session within 5 minutes. Let's wait for
Yeah,
everyone to join the
sure,
session.
ma'am.
Some other
Sure.
people also.
Thank you.
Okay, so let's start the session. Hello everyone, my name is Pooja Verma, MP Emeritus Research Scholar from IIT Kharagpur, and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering Department, IIT Kharagpur. This is a week 4 live and interactive session on computer vision. So I hope all of you have gone through this week video lectures. Okay, so for this week, uh, course content that you have studied, you must have been studied, that is a stereo geometry. So, okay, without wasting any time, let's solve some problems which will be very similar to your assignment questions. So, question one is consider a plane induced homography H matrix is given of a stereo imaging setup at epipole E dash, epipole point 3 2 in the right image plane and a point X 1 3 in the left image plane are given. Compute the epipolar line L dash on which the corresponding point of X will lie in right image plane. Okay, so this is a question. So any one of you have any idea how to proceed with this question? Would you like to try or suggest something how to proceed with this question? Okay, here we need to compute the epipolar line L dash in the right image plane corresponding to the point X in the left image plane. So, induced homography plane, that is H matrix, is given. Epipole in the right image plane is also given, and left image plane is also given. So, epipolar line L dash in the right image plane is can be calculated by which equation? Just a minute, let me answer slide so that we can solve. Okay, so the epipolar line L dash is calculated by equation E dash x, h, and x, where h and x are given. Now we need to find that E dash x. So first we need to convert this the image planes in the homogeneous coordinates. That means that epipole line first in homogeneous form in homogeneous coordinates. So first we are converting to the epipole line E dash, that will be already we know that we have to add that one as a third coordinate, and similarly for the image point X also. So 1, 3 and 1 transpose. So now we have converted in the homogeneous coordinates. Now first we need to find out this coefficient E dash X. So how we can calculate this one? So this is it. The cross product matrix is called E dash X for this epipole E dash, that is, now it is, what is this E dash X, it is in the form of that E dash Y and E dash X Z, right? Now how we can write this term E dash X? So already if you have gone through this video lecture, so you can write it in this form: 0 Ez dash, this is here minus Ey dash Ez dash 0 minus Ex dash, right? Now minus Ey dash Ex dash and 0 till here. Now if you write it again, so 0, what is it? Ez? Ez is here 1, it is 1, so minus 1 will be there here. Now next one is E2, so E2 dash will be 2. Similarly, Ez dash here it is 1, then 0 and minus 3, right? Now minus Ey is there, so Ey is 2, so minus 2, Ex is 3 and it is 0. So this matrix we have found from the epipole E dash, that cross product matrix. Now we have to calculate all these Hx multiplied by E dash x, that cross product. Okay, so now I am just going to another slide to solve it. So first we calculate the line that we are going to, this is the formula, so we can write it is easy, Hx. So first we can calculate this part, this two product, then we can calculate this one, right? So already we know that the plane induced homography matrix H is given. So H is, that is given already in the question. It is 2, 3 and 1, 4, 5, 2, 2, 1, 2, 4, 5, 2, 2, 1, 2, right? And what is the left image plane that we have got? This one is 1, 3, 1 in the homogeneous coordinates. So here we can write it H into X, right? So now, can you multiply and give me the answer? What will be the matrix? What will be the, what we will get? Okay, so multiply this row with this column, this row, this column, this row, this column. So 2 into 1, 2 plus 3, 3 is 9 plus 1, 1 into 1. Now next one, 4 plus 15 plus 2, right? Now next one is 2 plus 3 plus 2. Now what we will get? 12, here 21, 7, right? Now to find out the overall, we need to multiply this part, this hx. So e dash x we have calculated in the previous slide. So what we have got, 0 minus 1, 2, 1, 0, minus 3, minus 2, minus 3, 0. Now multiply with h into x, right? So what we have found, 12, 21 and 7. Now multiply the matrix, simple matrix multiplication. So here you will get 0 minus 21 plus 14, right? Here 12 plus 0 minus 21. Let me add. Okay. Have you calculated? Any one of you? Okay, now next one is minus 24 plus 63 plus 0, right? Now further just add and divide it. You will get minus 7. Here minus 9. Here you will get 39. Okay. So the epipolar line in the right image plane L dash, that is equal to that L dash what we have got, that is -7, -9 and 39. It is Hx and it is E dash x. So if you multiply it, you will get this one. So if you check in the answer, you will get option A is the correct answer for this question. Okay, so
Yes,
have you
ma'am.
understand?
Clear. Yes, yes.
Okay, okay. So moving to the next question now. Okay, so now next question is, consider a camera with the calibration matrix K uh, that is given, forms an image I of the word scheme. The camera is rotated about its center by rotation matrix, this one, by this, and form another image I dash of the same word scheme. If I and I dash form left and right image plane of a stereo imaging setup, compute the homography between I and I dash. So how we can compute it? Here the camera with calibration matrix K is given and rotation matrix is also given. Now from these two matrices we have to calculate the homography between I and I dash. Okay, so let me again take one. So when a single calibrated camera rotates about its center, if there is no translation, the mapping between the two images is pure rotation homography. Okay, so here we can say that this one is the h into x, and how that homography matrix can be calculated. K R K inverse. Okay, so where this K is the intrinsic matrix. Okay, and R is the rotation from the first camera to the second. So here K is given and rotation matrix is also given. Now what we need to do, first we need to calculate K inverse so that we can multiply. Okay, so can we calculate the K inverse? So how we can calculate? That is 1 by determinant of K adjoint of K. So it is a lengthy process. So just first we will calculate the determinant of K. So from here we can directly adjoint, you can calculate later it. I will write it here because for adjoint you have to calculate first cofactors, then you have to take transpose. Okay. So what will be the determinant of K? Can you at least can you calculate this one? 4, 4 minus 3, right? Here 4, 4 minus 3 minus 3 here in brackets. So if you just cross multiplication of these two components, 1 minus 3 plus 2, so 1 minus of 4. So here you will get 4, here plus 6 because 1 minus 3. Yeah, someone is giving answer, I think. Yeah, minus 4. Okay, let's see. And here you will get minus 3. So minus 3 into 2. So here you will get minus 6. So that will cancel out. Here you will get 4, not minus 4. Here you will get 4 only. Okay. Is there any confusion? Here you will get 4 because here minus and minus will be plus. Here you will get minus. Okay. So the K inverse you will get here 1 by 4 into adjoint of K. Okay. So I am writing it here, K inverse values. So can calculate it. I have calculated. but it will take some time. So in that case, we are not able to complete. So just you know that how to calculate the K inverse values, so you can calculate it. Okay. So here you will get 1 by 4. I'm just multiplying inside the directly. Here also minus 1 by 4, and here 1 by 4 you will get. Here 1 by 2 in the second row, 1 by 2, and here you will get minus 5 by 2. In the third row you will get minus 3 by 4. Here you will get minus 1 by 4, and here you will get 13 by 4. Okay, so K inverse these values you will get. Okay, now we have to multiply these matrices. So here it is a very long calculation because we have to 3 cos 3 matrix. We have to. Can you tell me, are you allowed to take a calculator, scientific calculator in your exam, or you will get that online calculator? So for homography matrix, already we know that K are K inverse. Here the because there is a lot of multiplication, and I have seen that some comprehensive questions are also there in the assignment questions. So that means that will come also. So please do practice for these matrix multiplications so that your at least your speed should be fast there. Okay, so let's first multiply R into K inverse, then we multiply into K. So already we know that rotation matrix is already given. So just 0.36, 0.48, and minus 0.8. Here minus 0.8, 0.60, 0.48, 0.64, and 0.6. This is the rotation matrix already given. And K inverse we have calculated. So little no space is there. So I'm just writing here K inverse value. So I'm directly in the form 0.25 because already minus 0.25. Here 0.25, 0.5. Here also 0.5. Here minus 2.5. Here you will get 0.75. Minus is also there. And minus 0.25 and 3.25. Just you multiply. So when you multiply these two, so a long matrix you will get because 0.36 into 0.25, then 0.48 into 0.5 multiplied by plus minus 0.8, 0.75. Then all these values that here you will get, these values you have to multiply with K, right? So I have also calculated directly in calculator. So direct value I have got, you can calculate it. Okay. So I'm just writing the K matrix which we have got already given 432 143 and 111. If you again further multiply these two matrices, so you will get a final homography matrix that is 4, 3, minus 19, 1.3, 2.5, minus 9.1, 1.02, 0.9, and minus 4.94. Here you will get. So if there is two matrices, one is camera with calibration matrix and one another rotated matrix is given, and now you have to find out the homography matrix between the two image points. So this one is the formula to calculate. So you have to calculate it. Okay. Here first you have to calculate the K inverse, then just multiply, matrix multiplication is there. Okay. Okay, so have you understand this question? So are you solving with me? Okay, so now moving to the next question. The next question is here the note is given. Okay. Assume that a stereo imaging setup has two image planes, left and right. Epipoles on left and right image planes are given as E and E dash respectively. Which of the following could be a possible right null vector or left epipole for the corresponding stereo imaging setup of the given fundamental matrix F? The fundamental matrix F is given. Here it is. What we have to calculate to find the possible null vector of the fundamental matrix. Okay, so how to proceed with this question? From this fundamental matrix, we have to calculate the possible right null vector. Okay, so to find a possible null vector, the right epipoles, it is from the fundamental matrix. So first we need to see the non-zero homogeneous vector, that is already we know that it is represented by E dash, that is in the form of X, Y and Z transpose. Okay, and that should be satisfy the value F E dash is equal to 0. Okay, so now already F is given, we have to satisfy this equation. So from here you will get X, Y and Z values 1, 3, 2, 1, 1, 0 and 1, 1, 0. E dash we have assumed that the let X, Y, Z is equal to 0. So from here the equations will be made, and from there we have to solve the X, Y, Z value, and this that will give the answer. Okay, so equation minus X plus 3Y plus 2Z equal to 0. Now next equation what we will get, X plus Y equal to 0, because just here we are multiplying this row, this column, equation 1, the second row, this column, equation 2, and the third row, this column is equation 3. Right? Now from here we can see that the equation 2 and 3 are identical. Right? So we need to calculate only two independent equations, either these two or these two. Okay, so from equation 2 or 3, we can write it like this. From equation 2, let's say x is equal to minus y, we can write, right? We can write it. Now we can put in this equation in equation 1.
Yes, ma'am. You can.
Okay, so just put in equation 1. So you will get y here, because in the place of minus x you will get minus y. So minus minus will be plus. You will get y plus 3y plus 2z. So from here, if you solve 4y plus 2z equal to 0, here you will get 2y plus z equal to 0, right? Or you can say that z is equal to minus 2y, right? Let me take. So what we have solved, x is equal to minus y and z is equal to minus 2y. Okay, so these two we have got x is equal to minus y and z is equal to minus 2y. These values we have got from the that equations. Now, so any non-zero solution is proportional to x, y, z values that we need to find, we are finding. So in the place of x, we can write minus y, right? And y is y only. Already everything we have written in the term of y. And in the place of z, we can write 2 minus 2y, right? If we here, we will take the y out. So what we will get? Minus 1, 1 and minus 2, right? Now, to make it in that homogeneous form, can we just multiply by minus 1? So that will be the, then still it will be the valid homogeneous form, homogeneous vector. So what you will get here? 1 minus 1, 2, right? Still it will be valid homogeneous vector. So we can just write 1 minus 1 and 2. Just check with the answer. You will get 1 minus 1, 2. So option B is the correct answer for this question. So this is a possible right null vector for the given fundamental matrix. Okay. So have you understand this question?
Can you repeat, ma'am, please?
Okay.
Last point,
Okay.
at least.
Last point. Okay. So have you
How
solved
we
till here?
concluded?
Okay. So here we have got this one 1 minus 1 and 2. You have understand till here?
No, ma'am. Can you come
Okay.
again?
Okay. From here. So here we need to calculate possible right null vector from this fundamental matrix F. Okay, so to calculate the fundamental, so already we know that E dash or E equal to X, Y, Z transpose. So these values we have to calculate possible right null vector. So that will satisfy this equation F E dash is equal to 0. So f we already know that it is given. Now we have to calculate this x, y, z values, that is e dash. What will be the possible right null vector? So if you multiply this row first column and then solve these equations. So from here we you can say that see that these two equations are identical, right? X plus y is equal to 0, x plus y. So you can, if it is identical, so you can remove anyone. So it is a, that means it has only two independent equations. So from here you can just calculate x is equal to minus y. So from here we can write it here like this. So x is equal to, that means minus y.
Yes.
Okay. Now come to the equation one. Put this x is equal to minus y value in the
Yeah, that's
place of
clear,
in
ma'am.
equation. Okay. So you will get z is equal to minus 2y.
Yeah, that's clear, ma'am.
Okay, so you have got x is equal to minus y and z
Yeah.
is equal to minus 2y.
Yes, ma'am.
So to any non-zero solution is proportional to, so we can write it in this form also. We have got x value and z value, so in the form of y, right? So we
Okay.
can
Okay,
write
ma'am.
it here
Got it.
like,
Yeah.
okay. So just make in this form already. So just multiply with minus 1, that will be still a valid homogeneous vector. Yeah.
Okay.
So
Yeah, understood, ma'am.
Okay. So yeah, someone is asking, ma'am, in case last two rows are not equal in F, then how to solve? So already we have solved in the previous classes also. If the equations are different, we had to calculate x, y, and z values. Right? We have to solve these equations. We have other questions also. We will see it. I have other questions also like this. Okay. So you have to calculate for all the coefficient. Okay. So now moving to the next question. Now next question is, consider a stereo imaging setup with two cameras. P is for the P matrix for left camera and P dash that is for right camera, that is represented by P dash. Compute camera center C and C dash in homogeneous coordinates. So here left camera matrix and right camera matrix is given. Now we have to compute the camera centers for both P and P dash in homogeneous coordinates. Okay. So how we can calculate it? We need to find the camera center C and C dash, and it is in the vector form already we know that. So just a minute. So a camera matrix in a homogeneous coordinates represents the projection from 3D world coordinates to 2D image coordinates. So the camera center C is the point of 3D space which is the camera is looking. So in the homogeneous coordinate, the camera center already we know that that equation PC is equal to 0, and we can write similarly for right camera matrix also P dash C dash is equal to 0. So we need to solve that equation PC is equal to 0, and where C is the camera center and P is the left camera matrix. Similarly, C dash is the camera center for right camera and P dash is a right camera matrix. Okay, so, so we can write it in homogeneous coordinate. The camera center is the null space of the camera matrix, that is PC is equal to 0. Already we know that if it is a right camera matrix, so it will be the P dash C dash equal to 0. So first we will calculate the left camera center. So for that PC is equal to 0. So P is given C. So we need to find the C to find vector C. So let's say it is in the form of X, Y, Z, W, right? Because the vectors will be there. So what we have to do, we have to arrange in such way. So PC must be equal to 0. So now can you just compute it? Simple. P matrix is given. Just let me write the P matrix. So 4, 3, 2, 0, 1, 4, 3, 0, triple 1, 0. Now we have to arrange this in such a way PC is equal to 0. So in this case, we can see that the last column of this matrix is all 0, right? So the last column of this matrix is all 0, right? What this means? That this means that any vector of the form of 0, 0, 0, W will be in the null space. So we usually what we do, we usually normalize it, normalize this by setting W is equal to 1. Okay, so here we can write it like this: C is equal to 0, 0, 0, 1 transpose. Okay, so because of this last column is 0, all 0. So what we do, just it is had to cut it down. So in that case, we can write this camera center for this. If you solve it, so you will get all the, you can solve it. You just do multiply x, y, z, w. So you will get only 0, 0. So you can check it also. So here x, y, z, w. So what you will get? 4x plus 3y plus 2z, w is 0, equal to 0. Similarly, for this equation is x plus 4y plus 3z equal to 0, and here x plus y plus z is equal to 0. So if you solve it, all the values you will get 0, 0, 0. X is equal to 0, y is equal to 0, z is equal to 0. Okay, so you can check it also. Okay, so here no values of it, it is in the homogeneous form, so W will be the W only. So that will be the in the null space. So what we are doing in the normal W, we are taking W is equal to 1. In the normal case also, always we make this W is equal to 1. We normalize by dividing all the coordinates in normal case also, right? We are doing that. So for this one, if they in the this matrix, if all the last column is all 0, so you can directly write it in this one, center of the matrix, the left camera matrix or either right camera matrix, whatever it is. So for the next, the camera matrix, sorry, camera center for left camera matrix, C is we will get 0, 0, 0, 1 transpose. Okay, this is for left camera. Now we need to solve for right camera itself. So now to compute for the right cameras, already we know that it is P dash C dash must be equal to 0. So P dash is given. Now to find out the C dash, let's assume that it is also X, Y, Z and W form, right? So can you just write and multiply it? So I am just removing this part so that I can solve it here. So have you understand this point? If all last column of the matrix is all 0, so we can directly write it. If you have any doubt, so you can solve it. You just solve this three equations, you will get x, y and z values 0. Okay, so now we have to calculate for right camera center. So P dash C dash is equal to 0. So P dash is given 1, 2, 2, 1. Here 4, 1, 1, 2, and next is 3, 2, 2, 1. C dash, we have already, we know that C dash is equal to X, Y. This is the camera center, W. For the right camera, W equal to 0. There we can add P dash, C dash is equal to, right? Now, we here, if you multiply, you will again get the three equations, right? So equations you will get X plus 2Y plus 2Z plus W is equal to 0. Here you will get 4x plus y plus z plus 2w is equal to 0. Now next equation is 3x, right? Multiply this row with this column. You will get 2y plus 2z plus w is equal to 0, right? Three equations you have got, right? So now how we can solve these three equations? So for getting x, y, z and w values, we have to solve these three equations. So what we will do first, subtract equation 1, equation 1 from equation 3. So what you will get, we have to subtract equation 1 from 3. Okay, so you will get another equation. So what we are getting, 2x, 3x minus x plus 2y and minus 2y will be the cancelled out, right? Here you will get 0. Here also minus 2z minus 2z will be cancelled out, w minus w. Here it is also. So what you are getting? X is equal to 0, right? Here directly you have got x is equal to 0. So now we have got x is equal to 0. So put this x is equal to 0 value in the remaining equation. So you will get some other equations also. Remaining equation. Then what you are getting here? So in the next you will get from equation 1 2y plus 2z if you are putting in equation 1 plus w is equal to 0. This is a one equation. Say, let's say it's equation number 4. Now put in the second equation, you will get y plus z plus 2w is equal to 0. You will get equation 5. Now what we need to do, so from equation 4, can we write it some another form? Equation 4. So we can write in the form of w also. So here you will get minus 2y minus 2z. Now substitute this w value in equation 5. Substitute and just writing substitute w value in equation 5. So you will get y plus z plus 2. Here you will get minus 2y minus 2z. So again you will get y plus z minus 4y minus 4z is equal to 0, right? So from here you will get minus 3y minus 3z. So from here you will directly get y is equal to minus z, right? Y is equal to minus z. Now next step what we can do? We have got x is equal to 0, y is equal to minus z. Now let me take another. So you basically you have to solve these equations and get the values of x, y, z and w. Yeah, w is equal to 0. Yeah, right. You have solved it. Okay, so now solving to the next. Then here already we know that already we have solved one place w is equal to minus 2y minus 2z, right? And we have recently got y is equal to minus z. So you just put in this y is equal to minus z. So here you get 2z minus 2z here. If you put here w is equal to 0, you will get, right? So now you have got w is equal to 0. So now what will be the our null space vector? So the null space vector uh, in the form of we have just got. So already we know that it is x, y, z and w transpose we have got in this form. So x is equal to 0 already we have solved. Y we can write the same because every equation is in the form of y. Now z we have got that is minus of y from here. You just do that z is equal to minus y. We can write it like and w we have got 0 transpose, right? Now can we write this equation in this form also 0 1 minus 1 0 transpose? We can write it, right? So you can say that this is a C vector, right? For the right camera matrix. So this solution has W is equal to 0. That means camera center lies at the infinity. It is if W is equal to 0 in equation, that means the camera center lies at infinity in the direction of this is another, but we have got finally camera center in the direction of 0, 1, minus 1. So this is our camera center that we have got 0, 1, minus 1, 0 transpose. Okay, sorry, this is a C dash. So let's check with the options. So C already we know that C we have got 0, 0, 0, 1, right? And C dash what we have got 0, 1 and minus 1 to 0. So if you check it, so none of the options are matching. Only C camera center for the left camera is matching, not for the C dash. So option D is the correct answer for this question. None of the above answer is matching with this question. So have you understand this question? How we are solving it? If two matrices, left camera matrix and right camera matrix are given, if we want to compute the camera centers for both, so this is a normal procedure to compute. Okay, so I hope all of you have understand. So now moving to the next question. So now next question is for the stereo imaging system mentioned in the equation 4 already. So compute both left and right epipoles. Now we have to compute left and right epipoles. So already we know that we have left camera matrix and right camera matrix. We have computed the camera centers for the both. Now we have to compute the left and right epipoles. So how we can compute the left and right epipoles? So anyone have any idea? Basically, what will be the equation or what will be the to compute the left and right epipoles? Okay, so 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 left and right epipoles. can be calculated from the camera center and left and right camera matrix itself. So the right epipole, that is E dash, is the already we know that is the projection of the left camera center C into the right image. Okay. So if you have these diagrams, if you have gone to these two left and right image, so what is a right epipose E dash? So it is the projection of the left camera from here center into the right image. It is a projection, that is E dash, and the left epipoles are the opposite. So it is a projection from the right camera center C dash. Let's see C dash into the left image. It is a projection of the right image from the left. It is a left epipole. Okay. So the epipole we can calculate by E is equal to P C dash. That means it is a left epipole E, and E dash is the right epipole. So right epipole can be calculated P dash C. Okay, this is the opposite of that. So already we have calculated C is equal to 0, 0, 0, 1 transpose, and C dash what we have calculated in the previous question, that is 0, 1, minus 1 and 0. The left and right camera P and P dash already is given in the previous question. So let's solve it. Left and right epipoles. So first we can calculate the left epipole P dash epipole, that is E is equal to P C dash, right? So the let's what will be the matrix for the P? So here it is a 4 3 2. Left camera matrix is this one, and right camera matrix P dash is this one. Already it is given. So for this we can write first P 4 3 2 0 1 4 3 0 and triple 1 0. Now C dash already it is 0 1 minus 1 0. We have calculated. So just it is a multiplication of these two matrices. So what will be value? 0 plus 3 minus 2 plus 0. Okay, now next one 0 plus 4 minus 3 plus 0. Now next one 0 plus 1 minus 1 plus 0. Right? So here what you have got, 3 minus 2 is 1, 4 minus 3 is 1, and 1 minus 1 will be the 0. Okay, so the left epipole E dash we have got 1 1 0, and now similarly we have to calculate the right epipole. Right epipole, that is E dash, that is E dash C. So similarly for the P dash is also given in the previous question, that is 1 2 2 1, 4 1 1 2 and 3 2 2 1, and camera center what we have calculated 0 0 0 1, right? So if you just multiply it, you will get here 0 0 0, last one 1 2 1, only because the last column will be the multiply. So 1 2 1 you will get. So E dash you have got So E dash you have got 1, 2, 1, and U that you have got 1, 1, 0. So none of the options here it is matching. So none of the above answer is the correct answer for this question. Okay. So have you understand? These two questions are the most questions. So from first part, you have to calculate the camera centers for C and C dash, and then in the next question, you have to calculate left and right epipoles. Okay. Okay. So I hope you have understand. Now moving to the next question. Anyone have any doubt? Can we move to the next question? Okay. So moving to the next question. Yeah. Okay.
Sorry, can you just go back to the previous slide? Uh,
Yeah. Okay.
yeah, so here how these values are derived like 0, 1, -1 and 0. It's
So
a
already it is given from the stereo imaging system mentioned in the question 4. So in the
okay.
question 4, we have derived these values C and C dash, these values itself. So P and P dash values already here given. Now in the fourth question, we have to compute the C and C dash. So in the fourth question, we have calculated or derived C and C dash. Then by using this, we have solved this left and right epipoles. Okay.
Sure, got it. Thank
Okay.
you.
Okay. Yeah. Okay. So now next question is consider a stereo imaging setup with two cameras, P that is left camera and P dash for the right camera. Which of the following options are correct? Which options are the correct? So here in the options they have given the fundamental matrix and right epipoles. These from the options. So that means we have to calculate the fundamental matrix and right epipole from these. Okay. So from there, we get to know which options are the correct options. Here, left camera matrix and right camera matrix is given. Now, we can say that fundamental matrix and right epipoles we need to calculate. Okay. Okay. So anyone of you, can you let me know how we can calculate it? So already we know that the camera center to calculate an epipole or something, we need to get the camera center, right? So the camera center C, what is it? Is the null space. Already we know that it is the null space of the camera, space of the camera matrix, and that is calculated by P C is equal to 0. So here P is given, and let's say that the camera center C is represented in the vector form, that is in the form of X, Y, Z, and W, right? And for any case, we have to make that W is equal to 1. So this camera center, we can write it in this form also, X, Y, Z, 1 transpose. We can write it in this form also. Okay. So here nothing is given. So we can take this homogeneous equation form also for the camera center. Okay. So now first we have to find out the camera center to calculate the epipoles or fundamental matrix, anything. So already here P is given. So we have to make PC is equal to 0. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. and x, y, z, 1 is equal to 0, right? So if you solve it, or otherwise in one previous question already I have told you, if the last column of the matrix in any matrix is all zeros, so directly we can write it, because if you solve it, you will get all the values x is equal to 0, y is equal to 0, and z is equal to 0. You will get the 0 values. From here, you can directly calculate it also. You can directly write it if the any matrix last column is 0, you can write it in this form directly: 0, 0, 0, 1, because here we are taking the homogeneous equation form. Here it is, or you can take a W. And at the end, we have to make this W 1 by dividing this W, if there is any value, by this W content. Okay, so we can write it directly in this form. Otherwise, if you solve it, you will get only 0, because x is equal to 0, y is equal to 0, and z is equal to 0. You will get. So camera center of this, the left camera matrix, what you have get? 0, 0, 1. Have you got this? Have you got this question? If you solve it, you will get all the values x, y, z, 0. So camera center at the end, for the left camera matrix, you will get 0, 0, 0, 1. Okay, transpose. Similarly, for the right camera center, we have to calculate also, or otherwise that is not required. So here, because in the question already we can see that we have to calculate only right epipoles, not the left epipoles. Okay, so to calculate the right epipoles, that already we know that the right epipole is the projection of this center C onto the right image plane, right? So to calculate the right epipole, just a minute, we can already we have seen in the previous question, that is E dash. Here we have to take P dash C. So already see that we have calculated, so don't need to require calculate C dash, because this is a long process. Similarly, you have to take the C dash is equal to x, y, z, and just you have to multiply this equation, and you have to calculate the x, y, z, and w values. So then you will get the camera center for the right camera matrix. Okay. So here they didn't ask, so we don't need to calculate it. Okay. Okay. So now what we need to do, we have to calculate now right epipole, that is E dash, that is equal to P dash C. So P dash is already given in this question, right? So P dash is this one, this matrix 1, 2, 5, 1. So here 1, 2, 5, 1, 2, 0, 0, 2, 3, 0, 2, 1, and camera center C we have calculated, that is 0, 0, 0, 1. Now if you multiply, you will get the right epipole. So let's see. So here you will get 1 into 0, 0, 2 into 0, 0, 5 into 0, 0. So in this case, you will get 1 here. Similarly, for this, so only this will be multiplied by 1. And for the last row also, 3 into 0, 0 into 0, 2 into 0, that will give the 0. And 1 into 1, 1. Right? So right epipole that you have got E dash is equal to, you can say that 1, 2, 1. We can write it like this. So right epipole you have got. Now next what we need to just check for the fundamental matrix. Okay, so how we can calculate the fundamental matrix? So now we have to compute the fundamental matrix. Okay, so fundamental matrix, already we know that we can calculate it by fundamental. Anyone of you know the formula how to calculate the fundamental matrix F? So it can be calculated by E dash x, E dash I, given 0, right? And where E dash X, what is this E dash X? It is a skew symmetric matrix of E dash. Okay, so E dash already we have calculated. So how we can write this skew symmetric matrix for E dash? So already, if you have gone through this video lecture, there is a one formula or one matrix that sir has made, that is 0 E z dash E y dash E z dash 0 minus E x dash minus E y dash E x dash 0, right? And already E, we can, it is a E x, it is a E y, we can say that, and it is a E z. So just put these values. So 0, Ez is 1, so minus 1 will be here, and Ey is 2, 2. Ez is 1, 0, Ex is, so minus 1 here, here minus 2, 1, 0, right? So I have you understand till here? Okay, so to calculate the next part, that is P dash I given 0. So already we know that P dash matrix it is given. This one, P dash, right? 1, 2, 5, 1. So we have to write in this form. So what we have to remove the last column. Okay. So by removing last column, you will get 1, 2, 5, 2, 0, 0, 3, 0, 2. Okay. So you will get this one by removing the last column of the P dash matrix. Now it is a simple multiplication of these two skew symmetric matrix and P dash I given 0. So just multiply these two matrices, you will get the fundamental matrix, right? So I am removing it from here so that we can calculate. So I hope all of you have noted down. Okay. So now to calculate the fundamental matrix F, we have to just multiply the skew symmetric matrix with this P dash I0, 1, 0, minus 1, minus 2, 1, 0, with 1, 2, 5, 2, 0, 0, 3, 0, 2. So can you multiply these two matrices? So what you will get? 0, 0 into 1, then minus 2, 2 into 1, row into column just multiply, and then plus 6 for the first one. Then for the next one, you will get 0 because 0 into 2, 1 into 0, 0. So here you will get 0 only. For the next one, we just take 0 into 5, 0, minus 1 into 0, 0, then 2 into 2, 4, you will get. Similarly for the this one, so you will get 1 plus 0, then minus 3, right? For the next, you will get 2 because these two are 0, so you will get 0, 0. Now for the next one, you will get 5 into 0 minus 2, right? For the last one, you will get minus 2 plus 2 plus 0 because 0 into 0. For the next one, we will get minus 4, and for the minus 10, 0 plus minus 0. Basically here you will get, so what you are getting here, minus 4, right? Sorry, 6, it is plus 6 minus 2 is 4, 4, 0, 4 here, then here minus 2, right? So 1 minus 3 minus 2, then 2, 5 minus 2 is 3, right? Now next, minus 2 plus 2 will be 0, minus 4, and here minus 10. So fundamental, this is our final fundamental matrix we have got. 4, 0, 4, minus 2, 2, 3, 0, minus 4, minus 10. Okay, so let's take, uh, let me just note it down here. What right people, what we have got, that is E dash. I'm just removing it from here for clarity. Okay, so E dash, what we have got, 1, 2, 1 transpose, and fundamental matrix what we have got, that is 4, 0, 4, right? Minus 2, 2, 3, just 0, minus 4, and minus 10. You can check it in the next slide. Actually, I have removed the right epipoles, but I have noted down. So from here, 404 minus 223, 0, minus 4, minus 10. So what are the other options that are matching? So option B and option C is the correct option for this question. Okay. Okay. So have you understand how to solve these questions? Okay. So I hope all of you are getting these questions how to solve. Now moving to the next question. Can we move to the next question? Okay. So now moving here also, the next question is also we need to compute the fundamental matrix. Here two left camera matrix and right camera matrix is already given. We have to calculate the fundamental matrix F. Okay, so already we have calculated here how to calculate the fundamental matrix. So now can you just calculate or suggest something to calculate the fundamental matrix? Okay, so for computing the fundamental matrix, already we know that first we need to find out the camera center, that is C. So we can calculate the camera center. So for left camera center, let's say it is represented by left camera center is C, right? And right camera center we can say that represented by C dash. We will see. So this is the left camera center. So already we know that, as we know that PC is equal to 0, right? So here what is our P? So P is given 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. And let's say C, we can say that X, Y, Z. In the homogeneous form, we can directly write it as a 1. Otherwise, we can write W also. If nothing is given, so for that you have to solve it. Okay. So X, Y, Z, 1 is equal to 0. Again, it is same. The last column of the matrix. The matrix is 0. So we can directly write the camera center would be 0, 0, 0, 1 transpose. Otherwise, if you solve it also, you will get all the x, y, and z values 0 here. X is equal to 0, y is equal to 0, and z is equal to 0 you will get. And the W for the homogeneous, we have to take it as a 1. Okay. Now For fundamental matrix, already we know that we have to calculate E dash x p I given 0. One another formula is also there. You have to calculate. You can rewrite it E dash x p dash or p plus. And already, if you know that it is we called pseudo inverse, pseudo inverse of P matrix. Okay, so if you okay, so now we have got the camera center C. So how we can find out the E dash, the skew symmetric matrix? How we can calculate the skew symmetric matrix of that one? Let me take the one another slide to calculate the. Okay, so to calculate the skew symmetric matrix, first we have to calculate E dash. That is a right epipole, right? So for calculate the right epipole, already we know that it is equal to P dash C. So P dash is given. C already we have calculated. This is a camera center. It is a right camera matrix, right? It is given in this equation that P dash. Okay. So now just calculate for E dash. Then we need to calculate the skew symmetric matrix E X dash. That's this one. So 1, 2, 2, 1, 4, 1, 1, 2, and 3, 2, 2, 1, and the camera center is what we have got. So 0, 1. So if you are solving an exam, if you are getting this 0, 0, 0, so directly you can write the last column of the that P dash matrix, because all these values will be 0 because first three values are 0, right? So directly you can write 1 to 1. You can check it also. 1 into 0, 2 into 0, 2 into 0 into 1 into 1. So this is 1 only. Okay. So right epipoles that you have got, this is right epipole 1 to 1. Now we need to find out the skew symmetric matrix. Matrix that is E dash X for the right epipole. We are calculating here right epipole. So E dash X, what is this? So I'm just writing the value. So already we know that this one E Z dash E Y dash E Z dash 0 E X dash here minus also minus E Y dash E Z dash 0. So just put the X, Y and Z values. So 0 here you will get minus 1, 2 here it is 1, 0 minus 1, right? Yeah, minus 2, 1, 0. Okay. So here we have to now calculate the fundamental matrix. Okay. So already I told you that the fundamental matrix is E dash X. This one is P I given 0. You can write it. Otherwise P dash P pseudo. If you just multiply these two, you will get only I values if you have seen. Okay. So you can directly write, otherwise P dash pseudo inverse will be equal to always I, that is identity matrix. So directly you can calculate it also here. Otherwise you can write this P matrix I in that form also already that we have seen. Okay, 0 minus 1 2 1 0 minus 1 minus 2 1 0. Then write that P matrix in that form. So you will get what will be our P matrix. So let me just a minute. That is we have to here for P dash matrix. Okay. Yeah, here it is P dash P. So 1, 2, 2, is our P dash matrix? So next is 4, 1, 1. So already I have written these values from there. You can check it. Okay, and just multiply these two matrices. What you are getting? So 0 into 0, then minus 4, 0 minus 4, then plus 6 you will get here. Okay, now for the this row, the next column, we will get 0 minus 1 plus 4. Similarly for this one, 0 minus 1 plus 4. Again, you will get. So can I remove it and multiply it from here? Or you will multiply. I can write it directly the answers. So this row and this column. Again this row, then next column, these values. So I can write it. So 1 minus 3, right? Now 2 minus 2 we will get here. Here next one is 2 minus 2 also. The last one is so minus 2 plus 4. Next will be the 0 only. Here minus 4, 2 into 2 plus 1, right? And plus 0 will be there because last is 0. So minus 4 plus 1 again you will get here. So just I'm writing it here. Just I'm removing it from here. So what you are getting the overall fundamental matrix, just you multiply, add and subtract this. You will get 2 minus 3 and sorry plus 3 you will get and 3 here also, right? Yeah. So 1 minus 3 will be the minus 2, 0 here and 0 here also. 2 minus 2, 2 minus 2 here. 2 you will get minus 2 plus 4. Here you will get minus 3. Here also minus 3. So this is overall fundamental matrix you will get. Okay. So let's check with the option 2, 3, 3 and then minus 2, 0, 0, 2 minus 3. So option D is the correct answer for this question. Okay. So have you understand this question? Are you getting any one of you have any doubt or can we move to the next question? Okay. So moving to the next question. Now next question is consider an image 0.56 formed by the left camera matrix, that is left camera matrix is given P of the stereo imaging setup and P dash is the right camera matrix and the fundamental matrix F here is it is given. Compute the left camera center C for P in a homogeneous coordinate and the corresponding epipolar line. So now we have to compute the left camera center C and their corresponding epipolar line. Okay, so here left camera matrix and fundamental matrix are given. So what we need to do first, here we need to calculate the camera center in the same way what we have calculated till now. So let's say the camera center C, that is null space of the P, that is represented by C is equal to X, Y, Z, W transpose. In homogeneous form, we can write it C is equal to X, Y, Z, 1 of transpose, that is, and right. And here image point is given, that is 5 is fine, that is given 5 6. To it is also, we can also represent this image point in the homogeneous form, that is it is in the form of 5 6 1, right. 5 6 1 transpose. Now to calculate the camera center, already we know that, that is PC is equal to 0, right. So P matrix, here it is given, the left camera matrix. Now we have to calculate center. So P, that is given as 2611, 2611, then 4542, 3132. Okay, and already we know that X, Y, Z 1 is equal to 0, that is PC is equal to, right. Again, what we need to do, we have to make that equation and solve the all the values of X, Y, Z, right. So let's check all the equations first. 2x plus 6y plus z plus 1 is equal to 0. Otherwise, we can directly write it is equal to minus 1 also. So here for the next equation, 4x plus 5y plus 4z plus 2 is equal to 0. Now next, 3x plus y plus 3z plus 2 is equal to 0, right. Or otherwise, we can write it 2x plus 6y plus z is equal to minus 1. It is also 4x plus 5y plus 4z is equal to minus 2. 3x plus y plus 3z is equal to minus 2. These three equations we have got. The one way already, which we have solved in the previous question, that just putting and subtracting, adding these from equations. The other way we can also solve for the x, y, z values by taking the 3 cross 3, this minor matrix also. Okay, let's say that we want to calculate the x values from, I am just calculating from the other way. One way, just you calculate from the, by subtracting and dividing from these equations and calculate for the x, y, z values. Okay, so the other way is by taking the determinant of, just remove the this one you will get the for the cx, x for x values, right. So just write this 6 1 1 5 4 2 1 3 2. Okay, so calculate determinant of this matrix by removing the first column, then remove the second column overall, then calculate the rest of the matrix, determinant of the rest of the matrix for y values. So can you calculate the determinant of this value to get the x values? What will be the determinant of this equation, this matrix?
6 into 4 minus 3.
Determinant of this. So let's calculate it. 6, 4 into 2, 8 minus 6 minus 1, and it is 10 minus 2, right? Plus 1. Here it is. So 15 minus 4, right? So from here you will get 6 into 2 minus 1 into 8, here plus 1 into 11, right. So here you will get 12 minus 8 plus 11. What will value you will get here? Here you will get 15. That means x is equal to 15 you are getting. So I'm just removing it from here and writing down so that we can calculate the other values. 15 we have got for x. Now we have to similarly calculate. Now what we need to do, just remove this column for the y values. Just a minute. Yeah, it is a 6, 5, 1, right? So just remove this column and write the determinant of. Now we have to calculate for 2, 1, 1, 4, 4, 2, 3, 3, 2. Determinant of this matrix. So can you calculate what will be the value? So 2, 8 minus 6 minus 1 again in brackets, 8 minus 6 plus 1. So here you will get 12 minus 12, right? Again 2 into 2 minus 1 into 2 plus 0. Here you will get, so what you are getting here, 2 overall you are getting 2. 4, 2 2 is 4 minus 1. Yeah, so this is it. Next column. So already you know that when we are calculating, one is plus, then minus, then plus, then minus, when normally in calculating the matrix. So because of that, here we have to over minus is from the overall matrix. So here you will get final answer is minus 2. Okay. Now for the next value, let's say it is z. For z, we have to calculate the determinant of what. Now what we need to do, we have to remove this third column and write the other matrix component. 2, 6, 1, 4, 4, 2. Sorry, we have to remove this one. So 2, 6, 1, 4, 5 here. 4, 5, 2, then 3, 1, 2. Just calculate for this one. For y values, what we have got, that is y is equal to minus 2. Right? Now calculate for the other one. So here you will get 2. So here it is 5. So 10 minus 2, then minus 6. Now 8 minus 6 plus 1. So 4 minus 15. Right? So here you will get 2 into 8 minus 6 into 2, and here you will get minus 11. So after that I'm just solving it here. So you will get 16 minus 12 minus 11, right? So if you just 16 minus 12, 4, so you will get minus 7. That means z value you are getting minus 7. Okay, so you have got x, y and z values. Similarly, you have to calculate for last one also, for last column. That what we are saying, it is W we are saying. Na? So for that one, we have to also calculate. So just I'm removing it from here. Okay, so let's say we are not representing it in the homogeneous form also. If you are solving by this equation, so you can write it as a W is equal to 1, because at the end you have to make W is equal to 1. For that case, if you are solving in this way by just uh, uh, subtracting, adding from these equations are getting. If you are using this form, what we are solving by using the determinant of that one, so you can write, for that you can write here W also. In that case, you cannot represent in the homogeneous form. Okay, for solving this type of question, you can write it W. If you are solving for your convenient or for your easy calculation, for that you can take W is equal to 1. Okay, in the homogeneous, for the homogeneous representation. So for the last one, so already we know that here we have to take minus sign also. So just remove the last one and write the rest of the matrix. So 4, 5, 4, 3, 1, 3. Now calculate the determinant. So it is a minus outside. So 2 here, 15 minus 4, then minus 6, 12 minus 12, right? 12 minus 12, then plus 1, 4 minus 15, we will get. Here you will get 2 into 11, minus 6 into 0 will be there. So here also minus 11 you will get. So here you are getting 22 minus 11. So in the final you will get 11. So after whole matrix it is a minus sign. So here you will get minus 11. So W is equal to you are getting minus 11, right? So what the values you have got X, Y, Z, W for the camera center? Okay, so X, Y, Z, W for the camera center C. We have got the values 15, minus 2, minus 7 and minus 11, right? These values we have got. Now to convert it into the homogeneous form, what we need to do? We need to divide. We have to make this last one W is equal to 1. So what we have to divide by this one. So 15 divided by minus 11, then minus 2 divided by minus 11, minus 7 divided by minus 11, and here minus 11 by minus 11 you will get 1. Okay, so now here you will get minus 15 by 11, minus 2 by 11, and 7 by 11, and 1. So if you further just you will take the ratio 15 by 11, you will get here minus 1 by 36. Here you will get 0.18. For 7 by 11 you will get 0.63, and for this you will get 1. Okay, so this is our values of the camera center. Now next, what we need to calculate? The epipolar line L dash corresponding to that center. We have to calculate, right? So I'm just taking the next slide. So have you understand this one? How we have calculated the camera center? You can solve this way also. Just you have to make the large procedure. For that I have taken here the little bit shorter. Okay. So now in the question it is given for the we have to compute the corresponding epipolar line L also. Okay, so how we can calculate the epipolar line L? So to calculate the epipolar line L in the right image corresponding to the point X, so L we have to calculate using the equation F into X, because we have to calculate the corresponding that image point. Okay, so image point is already given, that is 5, 6. We have converted it into the homogeneous form. F matrix is given already, fundamental matrix. Now we can use this formula F into X. We can calculate the epipolar line L. Okay, so F is given. The fundamental matrix is that is given. That is 4, 2, 3. I think, yeah, 4, 2, 3, triple 1, 4, 2, 3, 4, 2, 3, triple 1, 4, 2, 3, and image line that it is given 5, 6. We have converted it into the homogeneous form, so it has 5, 6, 1. So now if you multiply these two matrices, so 20, right? 4 into 5 plus 2 into 6, 12 plus 3. right? Now 5 plus 6 plus 1. Similarly here it is 20 plus 12 plus 3. If you add, so you will get 35, 12, 35. So that epipolar line L, that you have got 35, 12, 35, and the camera center you have got minus 1.36, 0.18, 0.63 and 1. Okay, so let's check from the options which one is correct. So 35, 12, 35 and minus 1. So option A is the correct answer for this question. Okay, so have you understand this question? Okay, so I hope all of you have understand. So moving to the next question. Now next question is given an epipole E, that is 4 3, and a point 6 3 in the left image plane of a stereo imaging setup. Compute the epipolar line L dash in the right image plane in the homogeneous coordinate system. Here we have to calculate the epipolar line L dash in the right image plane in the homogeneous coordinate system. So here epipole E and image point in the left image point is given. Now to calculate, here it is already given in the homogeneous coordinate system. So first we have to convert these 2 points in the homogeneous coordinate system. Okay, so the given image point and epipole convert it into homogeneous coordinate system coordinates. What we can write it? Epipole would be in the homogeneous 4 3 1, right? Transpose. Similarly, the image point x would be 6 1 1 transpose, right? Now we have to compute that epipolar line L dash. So to compute the epipolar line, that is epipolar line L dash, which is passing through this imaging point. So we can calculate it into the homogeneous coordinates by their cross product, that is E cross X, that we can calculate by E cross X. Okay, so already we know that how to compute the cross product. So I say K and the two epipolar lines are given. So it's 4 3 1 into the homogeneous coordinate system and it is for 6 1 1. Now just calculate as normal. I 3 minus 1 minus j, so 4 minus 4 minus 6, right, plus k 4 minus 18, right. Now next here you will get 2i plus, so 4 minus 6 will be the minus 2, so minus minus plus 2j minus, here it is 14k, right, 2i plus 2j minus 14k. So we can write it into a vector form also, like this 2 minus 14. We can write it into the vector form. Vector form, we can represent it. Now to normalize this vector form, already we know that the in the homogeneous cause the last one would be always 1. So to normalize this vector form of the epipolar line L dash. So what we need to do, so we can represent 2 by minus 14. Here also 2 by minus 14 into 1 transpose. We can write it like this, right? Now, if you just divide 2 by 14, you will get minus 0.1429. Here also 0.1429 and 1 transpose. So, this is our equipolar line point. 0. Minus 0.1429 minus 0.1429 and 1. So, from here you can see that this option B is the correct answer for this question. Okay, so have you understand? Yeah, okay. Thank you, Thilavati. You are continuously responding. Okay, okay. So moving to the next question. Now, next question is compute the essential matrix E provided calibration matrices of the two cameras in stereo setup as K, that is left camera. Here the representation for the left camera is K, and K dash for the right camera along with fundamental matrix F. Now here the left camera matrix, right camera matrix and fundamental matrix are given. We have to compute the essential matrix E. Okay, so how we can calculate the essential matrix from the left and right camera matrix? So the essential matrix E related to a point in a one image point to corresponding epipolar line in the other, but it is defined by the calibrated camera. So the essential matrix E is defined by the K inverse transpose F into K. So essential matrix is calculated by K dash transpose F K. Okay, left camera matrix transpose and fundamental matrix and right camera matrix. Okay, so here K, K dash and F is given. First, we have to calculate the K dash transpose. So first we just calculate K dash transpose. So K dash is given. We have to take a transpose of this matrix. What we are doing in the K transpose? Just converting row into column, column into row. So 1, 1, 2, then 2, 2, 3, and 1, 4, 1. So K dash inverse, K dash transpose we have got. Now first we can multiply K dash transpose or either Fk or these two first. Then overall. So K dash transpose into F first we are multiplying. So 1, 2, 1, 1, 2, 4, 2, 3, 1. And what is our fundamental matrix? Here it is given 4, 2, 3, 1, 1, 1, 4, 2, 3. Right? Just multiply these two matrices and you will get K dash transpose F. So you can write it here 4, 4 into 4, sorry 1 into 4, row into column like this. You have to so you will get 4, 2 plus 4, right? Just this one, then this one, this one, then last one. Okay. So I'm just writing 2 plus 2 plus 2. Here you will get 3 plus 2 plus 3, right? Now in the next this row into the first column like this. So you will get 4 plus 2 plus 16. Here you will get 2 plus 2 plus 8. Here you will get 3 plus 2 plus 12. Okay, now in the next one you will get this one. So 8 plus 3 plus 4. Now next 4 plus 3 plus 2. Right. Here next 6 plus 3 plus 3. Okay, so if you just add this, so here 448 to 10, then here 6, here 8, here 22, here 12, here 17. here 15, 9, 12, right? So K dash transpose F that we have got. Now again, we have to multiply this one with K, with this matrix. Okay, so I can take the other slide also. Okay, so already we have multiplied K dash transpose F. Now we have to multiply in this matrix K to find out the essential matrix E. So already we have calculated this one 10, 6, 8, 22, 12, 17, 15, 9, 12, right? Now the K matrix that is given, that is 4, 3, 2, 1, 4, 3, triple 1. Okay, now multiply these two matrices and you will get the final one. So here 40 plus 6 plus 8. So first row this column and first row second column like this. So here you will get 30 plus 24 plus 8. Now next one 20 plus 18 plus 8. Right. Here you will get 88 plus 12 plus 17. Here you will get 60 plus 9 plus 12. Here you will get 66, 22 plus 48 plus 17. Now here you will get 45 plus 36 plus 12. Right. Now, sorry, 44 plus 36 plus 17. Then 30 plus 27 plus 12. Are you getting how we are multiplying? Just first row, this column, then first row to the next column, then first row to the, for this value. Now similarly, second row, first column, second column, second row, third column for the second row of this one. Then third row, first column, third row, second column, and third row, third column. Now add all these values, you will get 48 plus here you will get for 54, here you will get 117, here you will get 81, here you will get 62, 131 and 63. And for the next 46, 97 and 69 you will get. So this is overall our essential matrix. If the right camera matrix, left camera matrix and fundamental matrix is given. Okay, so to compute the essential matrix. So from here you can say that 54, 62, this one. Option B is the correct answer for this question. So yeah, have you understand this question? Yeah, okay. So how to compute the essential matrix? Okay, so now we are moving to the next question. I have included here some theoretical conceptual questions. Okay, so just you have to take a guess. So next question is the fundamental matrix F for a stereo camera pair has a rank of 2. What is the geometrical significance of this property? Option A, it indicates that the epipoles are the coincident. It ensures that essential matrix is singular. Option C, it implies that any point in
Hello, ma'am.
the
I'm unable to see the question.
you are unable to see the question now.
Yeah, yeah, it's there. Thank you.
It's clear, ma'am.
Okay, okay, I have gone that mode.
It's okay, ma'am.
Okay, okay. So I don't want to show you the answers and explanation. I want to first guess you. Okay, that's fine. So this is the conceptual questions. I have included the five because from the last from these classes there are a lot of numericals and a lot of calculations are there, basically matrix multiplications. So I thought that I should include some theoretical concept. But in the assignment questions, I have seen also that mostly questions are the numerical questions only. So I would like to suggest to go with the theoretical first numerical, then some conceptual questions also. So I have included the 4 5 conceptual questions. Okay. So what will be the geometrical significance of this property? So options are there. It indicates that epipoles are coincident. Option B is it ensures that essential matrix is singular. Option C is it implies that for any point in one image, it corresponding epipole lines in the other image is uniquely defined. Option D is it means the two camera center are at the same locations. So option C is the correct answer. It implies for any point in one image, its corresponding epipolar line in other image is uniquely defined. So explanation is also given. If the fundamental matrix maps a point in one image to a line in another, if the rank of F were 3, then it would mean that for any point it mapping the result in a plane, not in a line. So if rank is 2, that ensures that the mapping is in the point 1D to the line, which is the definition of the epipolar line. So option C is the correct answer. Okay. Similarly, for the next question, what is the primary difference between the fundamental matrix F and essential matrix E? So, can you normally tell me what will be the difference between the fundamental matrix and essential matrix? So, already here it is defined that the essential matrix is a special case of the fundamental matrix for the calibrated cameras that incorporate only camera's intrinsic parameters. Okay, so option C is the correct answer. So essential matrix is used for the calibrated cameras for the related points in the normalized image coordinate, while the fundamental matrix is the more general. It relates point in the pixel coordinates for the uncalibrated cameras. And already we have seen that the relationship between the essential matrix and fundamental matrix where K and K dash are intrinsic camera calibration of these two cameras. Already we have solved one question on that. So this is a basically relation between the essential matrix and fundamental matrix. Okay. Now next conceptual question is consider the stereo setup for where two camera centers are the same. What can be said about the epipoles and the fundamental matrix F? So if the stereo setup where the two camera centers are that are the same, what can be said about the epipoles and the fundamental matrix F? So if the epipoles and are the coincident and located at the same point in the both images, then fundamental matrix in that case is undefined. Okay. So already we know that epipoles are the projection of the one camera center to the other camera's image plane. If the camera center are the same, the projection of the one center onto the other image plane is simply center itself. Since the epipoles are the coincident, so all epipolar lines would pass through the single point. Okay. So in that case, the fundamental matrix will not be defined. Okay. So for that, option C is the correct for this question also. Now moving to the next question. So here it is given that a point X in the left image and its corresponding epipolar line L dash in the right image, which of the following is always true? Option A, the point X must lie on the epipolar line L dash. The right epipole E dash must lie on the epipolar line L dash. Option C is the left epipole E must lie on the epipolar line L dash. Or option D, the epipolar line L dash is perpendicular to the baseline. So if the given point X in the left image and its corresponding epipolar line L dash in the right image, then the right epipole E dash must lie on the epipolar line L dash. Okay. So already we know that by the definition of the epipolar line, that is epipolar line is the line connecting the epipoles to the points corresponding location to the other image. Okay. So from here, the option P is the correct answer for this question. Now next and Last question is, how do you obtain the homogeneous line through the two image point P and Q? So already we know that to obtain the homogeneous line between the two image point P and Q, we are taking the cross product of the P and Q. Already we have solved one question of on that. So option B is the correct option. So this is some, I mean, ideas how they can give you the conceptual question on this. So that's why I have included some questions. This is based on the numerical question itself, but how we can represent in the question form. That's why I have included some questions. Okay. Okay. So thank you, everyone. Thank you for joining this session. I hope this session is fruitful for you all. And now, if you have any question, you can ask. Otherwise, we can close the session.
Thank you so much, ma'am, for your wonderful time.
Okay. Yeah. Thank you. Thank you.
All our
Thank
doubts
you.
are clarified.
Okay. Okay. So your questions are clarified now.
Next class will be on which date, ma'am?
Same. I mean Saturday, 6 to 8. It will be.
Okay, madam. Thank you.
Okay. The same day and same time it will be there.
Okay, ma'am. Thank you.
Okay. So yeah, thank you everyone. Thank you for joining this session. Now, if you don't have any doubt, you can leave the session.
I have only one doubt.
Yeah.
What is the percentage of theoretical question and mathematical questions will be there in the exam?
Okay. So see, for this concept, basically in the stereogeometry, and before that one also, it is mostly the numerical questions. But
Okay,
theoretical question, they can ask one or two like that, not more, but
not more than okay.
not more. It is more from the numerical questions. So practice more numerical questions. Try to practice more
Okay,
numerical questions, basically.
fine. Thank you.
Okay.
Bye.
Bye bye.